Welcome again to St Ed's Geography revision videos, this time revising the meanders and oxbow lakes for the water on the land unit, which of course is in the physical geography paper. Right, we're going to look at how meanders are formed first, and then we're going to move on to oxbow lakes. But just before we start, you'll see I've put a picture in here from the revision guide that we use. I highly recommend it, and that's why I've put it in here to give you a nudge if you haven't already bought one. It really will help your revision and give you a structure and help you with everything. So, meanders, how are they formed? Right, let's start with the most important thing. Down the bottom of this slide in red you can see I've written key point. I'll just give you a chance to read that. Got it? It's all to do with the speed of water flow. Where the water flows faster, it has more energy. Where it has more energy, it can do some more eroding. Where the water flows slower, it has less energy, hasn't got the energy to erode, probably hasn't even got the energy to transport material, so what it does is it deposits it there. And the water flows faster on the outside of the bend. The water flows slower on the inside of the bend. So, faster water flow on the outside of the bend, more energy on the outside of the bend, more erosion on the outside of the bend. And it's just the opposite for the inside of the bend, where the water flow is slower, it has less energy, it can't erode, it can't really transport, so it deposits material. Now really, both diagrams on this page just repeat what I've already said about the fast and the slow flow. Diagram A at the top there is the plan, the overhead view of a meander, and diagram B is what you call the cross section. You could be asked about meanders either from that overhead, that plan view, or from the cross section, so make sure you know both. But in both cases, outside of the bend, faster flow, more energy. Inside of the bend, slower flow, less energy. Okay, let's have a look at that in slightly more detail. So you can see from the top diagram, if you have a look at the key, you can see the dark brown is the eroded area, the lighter brown where deposition's happening. They've got a black arrow for the fastest current, and you can see what they call lateral erosion, sideways erosion with the star, and the plus is deposition. So follow that black arrow where the fastest flow, and as it comes down you can see it's going to hit that corner there and it's going to erode there. The fastest flow comes round here, round the outside there's going to be erosion here with a river cliff there, and around and again into the next meander, and there's erosion there. Whereas on the inside you can see slower and there's deposition. Now have a look at the second diagram, diagram B, down at the bottom. Here's the outside of the bend, here, with the river cliff that we talked about. So this bit here, where it says Y, that relates to the outside of the bend of those three meanders where it's dark brown. And you can see it says fastest current. Bank on the outside of the bend is undercut by lateral erosion. You get a river cliff here, and it's deeper, it's scoured out, and the fact that it's deeper also then feeds back into you can have a faster flow as well. Now on the inside you've got slower current, so there's more deposition. The sand and the shingle here you can see is deposited on the inside of the bend, and it's what's called a slip-off slope. So combine those keywords with the idea of the flow of the river, and you've got your 4 marks in any exam question on meanders. Okay, let's get you thinking a little bit here. I've got 6 labels, 3 of which go best at point A, 3 of which go best at point B. If you pause the video now, see which ones out of 1, 2, 3, 4, 5 and 6 go best at A and which of them go best at B. Okay, let's have a quick look then at what the answers should be. A is the outside of the meander. So at the outside of the meander we have faster flow, which is number 6. The faster flow will cause a deeper river channel, which is number 1. And the faster flow will also cause some erosion, and as a result a river cliff formed there. Okay, which leaves us with B, which is the inside bend, where there is slower flow, shallower river channel, shallower river channel, and what is called the slip-off slope. Hope you got all 6 out of 6 there. Okay, so oxbow lakes, how are they formed? Well, I've got 2 diagrams here, one from the revision guide at the top. You can see they do it in the sequence 1, 2 through to 6. And I've also included the same diagram I had earlier down at the bottom here to show how it links together with meanders. So we'll start in fact with the one at the bottom. Here's the meander drawing again. We can see the erosions happening in the dark brown areas on the outside of the bend. Now basically what's going to happen, eventually you can see this area here is called the neck of the meander in between those two there, and those two are going to join up because that erosion here at the top is going to join that erosion here, and eventually the river will just break through. And it normally does that in a period of flood when the water's highest, and it will break through the banks. Now the whole sequence is shown better. The diagram's at the top. Here's the neck in between the meanders here. The water's flowing round at first. Then if you go into number 3, normally the river will break through this neck in a time of flood, and the river will then flow the shortest course, and so we'll end up with a straighter channel flowing through here. So down at the side, eventually with very little flow here, around in this area now, and then into here on the last diagram, with very little flow, what will happen then is there's just deposition happening, and all the material that's in suspension will deposit down onto the bottom of the oxbow lake, and will eventually end up being cut off completely from the rest of the river by this deposition, and the river will become separate from the river, which will be then flowing down this way when the oxbow lake is here. Now I couldn't resist also throwing this picture in here, taken by Commander Hadfield out from the space station, and you can see a river flowing up from the top right all the way down here, with loads and loads of meanders in, and all the old oxbow lakes you can see where the river used to flow and have been cut off, and eventually these oxbow lakes get filled in over time, as we've said, because there's no flow, there's no energy to the water, so it'll all just be deposited what's ever there. And you think of all that stuff, material that's been held in suspension, that'll eventually settle down onto the bottom of the oxbow lake and form almost like a marsh, which will fill in over time. And as ever, the best way to revise and the best way to know how your revision has gone is to test yourself with some exam questions. So here are 2, one on meanders and one on oxbow lakes. Both 4 marks, so you need to think to yourself, how am I going to get level 2? Make sure you get at least 3, if not 4 out of 4. You need to have developed points, linked points. You need to have the whole sequence. You need to have it in the correct order, and you need to be using keywords. Always those 4 or 5 things. Right, a labelled cross-section. You need to know obviously what a cross-section is. Check back earlier in the video if you're not too sure. And also you need to be able to draw the inside and the outside to show that they're different, to show that the meander is asymmetrical. It's not the same as one side or the other. To show you've got a gentle slip-off slope with shallower water on the inside. You've got a river cliff, deeper water on the outside. And finally, on that diagram, there's one thing that we've noticed with the exam board in the last couple of years, that they've become really strict on how you label. Make sure the line from your label goes to exactly the right place on your diagram. Not even a couple of millimetres off left or right. Make it go to exactly the right place. It could make the difference between a mark or 2. Now everything you need to be able to get 4 out of 4 in both questions has been in this video. And if we look at that second question, explain the formation of an oxbow lake. When we did this in class, and when a previous year group did this question, there was one thing they weren't so sure on, which was just that final bit about how deposition ends up cutting off the oxbow lake from the actual river itself. So make sure you include that. In other words, the whole sequence. So if you want to, please get in your answers to me. I'll mark them as soon as I can, and I hope the rest of your revision goes well. Good luck.